Hello, everybody. Now we're going to turn to organisms with more than one cell, and talk a little bit about the impacts of oil on marine life that's multicellular. And what we're going to do, we have two presentations that are about 10 minutes each, and then we're going to have a discussion with all of the panel, and then take some of your questions. So first up is Steve Murawski, who is the Peter Betzer Endowed Chair of Oceanography at University of South Florida. Another, Peter Betzer, another amazing Gulf scientist. And Steve is a specialist in population dynamics and marine ecology, and he is the director of the Center for Integrated Analysis and Modeling of Gulf Ecosystems, CIMAGE. Steve, up to you.
Thanks. Just waiting for the slide deck to come up. Trying to wrap our arms around everything, core area 3 in 10 minutes. Obviously a big challenge. I'll try to talk faster than Mandy. We'll see how it goes. Okay, so the punchline or the bottom line from this particular presentation is that it's not over yet. You know, we're 10 years into Deepwater Horizon impacts, and as you'll see in a few of the slides that I have illustrating the point, there's lots of ecological effects that haven't come full circle in terms of what's going on in terms of populations, communities, et cetera. So there are a few overarching issues when we look at Deepwater Horizon impacts on the Gulf biota, and this is, as Margaret said, from anything from microbes to mammals. Certainly changes in resource abundance and the demography of those populations. The nice thing about some of our time series is that they predate Deepwater by, in some cases, several decades, so we can look at that. Secondly, the recovery times, and that is how would we expect various biota to recover from a single acute effect like this, over what time frames. The pertinence of the concept of baselines. As was said before, I mean, this is not a static baseline, and particularly a static baseline in terms of these animal populations that have multiple simultaneous stressors on them, including harvesting. The notion of contaminant concentrations before, after, during, and certainly the control and impact parts. And so trying to decipher all of that. The notion of sublethal impacts on populations and communities. Clearly, Deepwater has been kind of the evolution of sublethal impacts, where the model prior to Deepwater has been LC50s as a way to measure impacts of things like oil and dispersants. The notion that we've had habitat effects, and that is direct impacts on habitats, some of which there has been recovery from, and some of which there never will be recovery from. The impacts of oil spills on oil spill countermeasures, that is, the things that we did during the spill over and above the oil itself. The effectiveness and the consequences of restoration activities, and I'll have a slide or two on that. And then what I would call the revelation of black swans, and there have been a number of things that we didn't plan for in this and that have been important. One of the points I wanted to make is that, you know, John Farrington talked about this a little bit with the Paul Galtzoff example. That is, Galtzoff talked about two ways of actually measuring impacts on oysters. One was to go out in the field and measure it, and the second approach was to do laboratory experiments. Well, if you actually look at the epistemology, or the how we know what we know concept, there really are four pillars of direct observations, and they include going into the field and doing surveys of things, the laboratory experiments that many people have talked about, but we also have the comparative spatial analysis, and this gets to this notion that can we find a control in the real world, and in some cases can we substitute space for time in the sense of trying to interpret effects. And then we've got the whole field of doing in situ field experiments. Now the point of all of this is that the synergy between these things is really important, and I'd like to illustrate a few examples of that. And the notion of trying to understand these things from that prism is that we really need models to actually help us predict, for example, Deepwater Horizon version 2.0. And that is everything we know about oil spills conditioned on what we observed or can we actually make some predictions about what would happen under different circumstances? So in the case of Core Area 3, we've parsed the ecosystems into 4 large groups, and I'll try to illustrate a couple of examples from each. The nearshore coastal area, the continental shelf, the open ocean pelagic, and the deep benthic. And of course, these are interrelated ecosystems, but telling this story is so complex, and it's more than just a series of what happened to species X, that this is a useful way to cast this. So one of the really, this is certainly a black swan, and that is the impacts on these deep water mesopelagic species. And so this was a synergy between the NERDA work that was originally done and the Deep End Consortium. And you can see that there have been massive changes in the abundance almost across all biota and across all depth strata. And so with this large decrease in these populations, obviously there's a potential for cascading effects. Given what we know about the life histories of these animals, it may actually take quite a long time to recover. Now, so the question is, of course, is this a deep water horizon effect, or is this the natural variability of these populations? Hard to decipher without one of the other legs that you've got in that 4-leg stool. So just continuing on the themes of offshore work, a major investment by GoMRI has been tracking offshore whales and dolphins. And so this is based on passive acoustic monitoring of these deep deployments. And you can see that for Mississippi Canyon and Green Canyon, the areas along the shelf, we've seen significant declines in things like sperm whales and delphinids, whereas down on the dry tortugas, you can see that some of these populations are actually doing better. And so using passive acoustics, this interrelates, I think, to the deep end work, where those are the prey for these foraging animals, and so there's perhaps a story here that conflates. In terms of some of the things that have happened both in deep water and the shelf, certainly MOFSA was a black swan in terms of delivering not only marine snow, but also oiled contents of marine snow to the sea bottom. And so that's resulted in a plethora of ecological effects. And perhaps some of the best documentation of this has been the work that Paul Montagna and his colleagues and also Patrick Swing have done. And it's really interesting because in some cases there were benthic data in terms of pre-spill baselines that allow us to look at some of this. And actually you see some partial recovery of the myobenthos, but in terms of the megabenthos, it's been a long haul. And so these data go up to 2015, and so it's likely that we're going to take a longer time. In terms of some of the other, the shelf impacts, we've seen a variety of impacts on the shallower water reefs, and they basically seem to be less impactful as you go distant from those reefs. One of the nice time series that we've got on the continental shelf, of course, is the series of surveys that the states and the federal government have taken. And so on the right side of this panel is results from the CMAP trawling surveys that have been taken over time. And you can see that compared to the pre-Deepwater Horizon baseline, many of these populations are at relatively low levels. Some of them are recovering faster, and then of course you've got lionfish, which are really becoming extremely abundant in the system. And the lionfish is a great example because it shows how unpredictable the system actually may be. And so you can see the abundance of lionfish on both artificial reefs and natural reefs. And so there's been a number of modeling efforts to look at the impacts of lionfish on some of the populations that have been severely impacted consistent with the Deepwater Horizon time frame. And that especially includes the shallow water demersal fishes. And you can see the simulations that are related to that. So we can expand the window a bit and look at some of the work that GoMRI sponsored all around the Gulf. And so one of the things that we can tell from looking at things like fish bile and in the sediments is that there certainly are hotspots of pollution, particularly up around the Deepwater Horizon, but you also have hotspots of pollution off Tampa Bay and off the northern Yucatan. These must be different sources than deep water, and so this points to this notion of trying to deconvolve the source of environmental pollution to its progenitor. One of the really interesting sublethal effects that we saw, which emphasized the point of the interrelationship between laboratory studies and field monitoring, is this sort of ugly-looking external skin lesion on a red snapper. And this was a problem brought to us by the fishing industry itself. So this was an example of citizen science. So basically, a number of studies were initiated to monitor this in the environment, which was pretty cool. And then ultimately, under the Small Investigators Grant, we're able to actually induce the occurrence of skin lesions with a fairly complex experiment which looked at dosing with oil and then also with high bacteria loads. So it's sort of an example of how those two legs interplay. Now, so Tamai had a SAR image of this particular area and was talking about how effective the use of freshwater inputs were. So if you look at this SAR image, and this is from June 2010, by then there was about a month of diversionary flow into the Barataria Bay. So you can see that the oil has crossed Barataria Bay mouth and is up in the upper bay. The point here is that it may have been somewhat effective in keeping the oil off, but it certainly wasn't completely effective. And you can see that the inlets are hardly a barrier to this. Again, this is after a month's worth of that work. Now, some of the work that's gone on in the Barataria Bay, and this is Gene Turner's work, and you can see that on the left-hand side, that's the PAHs and their alkylated homologs in terms of the relative concentration. So the green is pre-Deepwater Horizon, the red is right after Deepwater Horizon landed, and the blue is in, I think it's 2015? Yeah. So what happened was the concentration of PAHs in the sediments went up by a factor of 1,000. The good news is it's gone down by 2 orders of magnitude, but it's still an order of magnitude higher than the baseline. And so this creates a lot of issues. Just briefly, there's a lot of interest in economic resources, in things like oysters. The fishery closure resulted in decline in the long-term fishery landings. In some cases, they increased rather quickly, but then in some of these locations, particularly in Alabama and Mississippi, you've seen further declines in oysters. And this is also in the fishery-dependent data that the states have gathered. One of the last technical issues I want to talk about was predictions of the restoration impacts. And this is a really interesting and really important study that the Water Institute did in coastal Louisiana. What it says is basically, in the lower, particularly on the western side of Barataria Bay, the diversions, not only the existing ones, but also the ones to come, may reduce the salinity of the lower Barataria Bay by up to 10 parts per thousand. And so that's going to have ramifications for salinity-dependent species like oysters and certainly bottlenose dolphins, which are confined to that area. The interesting thing on the end of these simulations is that you can see that they hook up in terms of salinity, and that's the effect of sea level rise in the long term. So it's really important. In terms of the impacts on health effects on dolphins, there's a collage here of things. The most important thing is on the upper second from the left panel. This is a comparison of the cortisol levels in bottlenose dolphins between Sarasota Bay, which is the one that's hardly detectable, and a time series in Barataria Bay. And so you can see in terms of that stress hormone, there's really significant issues. And the projections are that it'll take decades to recover that population, if at all. So in terms of some of the conclusions, I won't dwell on this. It's a long list. I would say that we've learned a lot from the long time series that we have for many of the natural resources. The recovery times, depending on life history, are going to be, could extend for decades from where we are. There's lots of impacts both in the deep and the shallow. The deep ocean has to be an area of emphasis going forward because that's where the oil industry is going to go. And then lastly, I'll just make a point here that many of the issues that we're talking about in terms of the impacts on biota are actually going to be evaluated in the sessions that we have in this particular GoMoses meeting, this is going to be a really pivotal one. So I would recommend these 9 sessions that deal with the natural world. Thank you.
Okay. Thanks, Steve. Now we're going to hear about some large mammals. Melissa Finucane is a social scientist and behavioral scientist at RAND, and she's also a senior fellow at the East-West Institute at University of Hawaii. And she is the director of the Consortium for Resilient Gulf Communities, and this consortium was designed to assess and address community impacts resulting from the Deepwater Horizon oil spill. So she's going to tell us about some interesting large mammals.
Thank you. While we're waiting for the slides to come up, firstly, thank you for the opportunity to be on this panel. I wouldn't be here giving this presentation if I hadn't been volunteered by Paul Sanderfer, so you can address all questions to him, especially on physical health, which is really not my area. Let me just start with setting the context here. I am going to give you a slide that gives the bottom line up front, basically, on what we knew before Deepwater Horizon and what we know now in terms of human dimensions of the oil spill. But in terms of this theme 5 that our consortium was funded by, I see the slides up there, but not on the screen in front of me. That theme was dedicated to behavioral and socioeconomic impacts, population health, community capacity, environmental risk assessment. And personal communication with Chuck Wilson a few months ago said about 4.2% of GoMRI funding that was awarded through the competitive grant process, in other words, 16.8 million of the 400 million, was allocated to that theme. I think it was in the David Murphy paper, or maybe it was Paul's paper, only about 2% of the GoMRI-funded PhD students were from social and behavioral sciences. I compare that with 30% in the marine sciences and 28% in engineering. So the context and the point that I'm trying to make to start with is that plainly, without the chance to do the necessary studies and develop future generations of researchers in this field, it is going to be hard to make much progress. But let's see what we can say given that context. So the first question is, how much research has been done on human populations before Deepwater Horizon and GoMRI? It was called or characterized as a nascent field. I'd say we'd still now characterize ourselves as a pretty young, very young field, and our limited knowledge reflects the opportunities to study human dimensions of oil spills. But given that, what are the health impacts? Before Deepwater Horizon, I'd say the common assumption was that higher exposure, either directly through, say, cleanup work, or indirectly through economic impacts or the stress of living near an oil spill, was associated with physical symptoms, headaches, nausea, skin conditions, sore throat or eyes, etc., as well as mental health symptoms. And most typically, we've studied depression, anxiety, event-related stress, and post-traumatic stress disorders. What I'd say now is that I think the evidence is mixed. I'm less familiar with the physical health work, but certainly in terms of mental health, and I'll talk in a little bit more detail in a couple of slides, it's unclear what the impacts are. Similarly, for the economic side of the equation, before Deepwater Horizon and GoMRI, the standard assumption was that fishing, oil and gas, tourism were the most hard-hit sectors. But now I'd say, with some additional work, again, the evidence is mixed. It depends a lot on the analysis, the level of analysis, whether you're doing a macroeconomic analysis or more of a micro-household look at impacts. In terms of who is most vulnerable, women, children, older adults, and fishers have been commonly touted as the most vulnerable. But now I'd say the change is, with the research done over the last few years, is that we think about the frame in terms of who has the highest level of exposure, direct or indirect exposure, who has the greatest stress from these events, who has the greatest dependency on natural resources. So you may end up with sociodemographic factors or variables correlating with those expected mechanisms of exposure and vulnerability, or you may not. And then finally, what helps mitigate impact? Certainly there's always been thought an important role for social, familial, and economic aid or support as modulators, particularly of mental health symptoms. And I think what we'd say now is that it's still true, but social support in those forms doesn't guarantee a better outcome for everyone. And also over time, aspects of social capital that are important can change in the direction of their relationship with the outcomes being studied. So if I'm not going to be pulled from the panel yet, let me move on and see if we can dig a little deeper into some of those findings. In terms of physical health, the research has shown that dispersants lowered volatile organic compounds, but increased aerosolized particles. This one is attributable to Paul. Dispersants were identified as containing possible human obesogens in the form of surfactants in core exit. Hydrocarbons of crude oil were not found to enhance the growth of bacteria, in particular the one that causes gastrointestinal illness. However, tar balls on Gulf beaches had 10 to 100 times the concentrations of the bacteria compared with adjacent sand and water samples. Concentrations of oil compounds in seafood were at pre-spill levels soon after the spill, but some questions have risen about whether the safety limits are sufficient for some vulnerable groups, in particular those that perhaps eat more seafood. And one conclusion is the need for more comprehensive, reliable measures of seafood safety and more comprehensive risk exposure analyses, including multiple exposure pathways being examined simultaneously. Other findings related to physical health from work outside of the GoMRI effort, both lab and worker studies have shown impacts on lung function and increased risk of cardiovascular disease, and also in folks living closer to oil spills or in the proximity of oil spills, a self-reported poorer health status amongst those folks. In terms of mental health, so I'm going to just go through quickly some mental health, then economic impacts, and then community distress associated with Deepwater Horizon oil spill, and then talk a little bit more about what kinds of infrastructure we need to improve and move us forward in these human dimensions aspects of research in this field. So mental health, I'd say we have evidence, certainly from several studies. My own consortium for resilient Gulf communities did a large telephone sample across the 5 Gulf states. Residents, there's the Watch study, there's multiple studies that have shown rates of depression, anxiety, and PTSD that seem a little higher than the general population. In our study, we had about 20% of our sample screening positive for depression, a little lower for anxiety. However, in contrast, 2 large population-based longitudinal studies that were cross-sectional, but comparing pre- and post-spill data, suggested that there were minimal or modest impacts on mental health of the general population. Of the drivers of mental health symptoms, it seems that certainly the life disruption caused 2 folks who reported higher levels of mental health symptoms seemed to be a key factor, especially income loss, but also prior trauma, whether it was related to the oil spill or not, was a key driver of greater reports of those symptoms. Higher levels of social capital tend to be protective against stress in most cases, except as has been noted by a few speakers earlier, groups with a high attachment to natural resources such as fishes. In terms of economic impacts, I have to try and speak faster than Mandy here. I'd say again we have an interesting mixed set of findings to report. Aggregate analyses by industry show substantial impacts, at least in the short term. One study done early on using a predictive methodology anticipated or predicted that 3.7 billion in revenue losses and 22,000 jobs in commercial and recreational fisheries and mariculture would occur over a 7-year period. But in contrast to that predictive methodology, some economists from my own team did a more recent analysis where they looked at different fisheries and the observational data that we had, and they used a difference in difference approach and found that, for instance, in blue crab landings, the landings took a nosedive in 2010, largely driven by the reduction in crabbing trips because of the closures of the fisheries. But both trips and landings had largely recovered by 2011. They also reported that the impacts were highly heterogeneous. Employment and wages in some areas actually improved, especially in Louisiana and Alabama, where there was a lot of cleanup work going on, but decreased in other areas outside the Florida Panhandle, for instance. In other areas, there was no change. So contrast that with some of the survey work I talked about earlier, found that reports from households and individuals at that microeconomic level suggested that people were reporting very negative impacts on their finances in the short term, but also in the long term. So some of our studies have been done 6-7 years after the Deepwater Horizon oil spill, and they're still finding people are very, reporting to be very impacted economically at the household level. In particular, people earning $25,000 or less for their household were reporting the most severe impacts. Finally, in terms of community and social distress, a lot of sociological studies by our team and others suggesting that there was severe disruption to the social economic environment that would negatively impact community well-being in terms of reduced trust in authorities, weakened social networks, increased perceptions of inequities, and increased domestic violence. A telephone survey by Liesl Ritchie, Dwayne Gill, and others in 2013 found that almost 23% of their sample, this was a sample of about 1,200 folks in Alabama, were personally involved in some type of claims or settlement or litigation activities. And in addition, nearly 16% indicated that someone else in their household was involved in some kind of settlement or legal activities related to Deepwater Horizon. Nearly 65% of those surveyed indicated that the compensation issues had been as distressing as the oil spill itself. So their analyses basically were showing that being part of a compensation process like that was one of the strongest contributors to intrusive stress among coastal residents. Our studies and others have shown that the community impacts have been unevenly experienced by different groups. Certainly social capital is important in many contexts unless your entire social network is being negatively impacted, such as in the fishing communities. How am I doing for time? Wrap it up? Yeah. Okay, I'm going to skip. You can ask me about policy suggestions. This graph is just from a commentary that we published November last year in Disaster Medicine, Public Health Preparedness, showing that the vast majority of studies are done a month or more after events such as Deepwater Horizon. So there is a significant need, and there are ways to do longitudinal research before, during, and after oil spills on human populations. This is a schematic or conceptual framework from a workshop that was led by Paul Sanderfer and Bert Singer, coming out in a report that is soon to be released, suggesting one way that we might integrate both physical and mental health studies using the backbone of existing cross-sectional longitudinal studies that already exist, but also adding new longitudinal cohort studies in the Gulf of Mexico and perhaps some disaster-specific cohorts also to help fill the gap in human dimensions research. Let me just finish by saying I think this is really a huge gap in our understanding, not only in terms of exposures and exposure pathways and physical and mental health impacts, but also understanding the effectiveness of different interventions. If we want to do something to help communities impacted by oil spills, we need to know what is working, how long it takes to work, how long these effects continue. And I think we have huge potential. We have terrific methodologies in other disaster recovery areas, and I think there's a huge opportunity for making great strides in the future.
Great, thank you. So I'd like to introduce the rest of the panel, and we'll have some questions for them. So to my right is Cynthia Smith, and she is the Executive Director and Chief Medical Officer of the National Marine Mammal Foundation. And she is the director of a GoMRI-funded project to understand the reproductive failure of marine mammals after the Deepwater Horizon oil spill. And in 2019, she was named Red Bull's Hero for the oceans for her work. So, and then on the other side of Melissa is Paul Sanderfer. He's director of the Center for Coastal Environment and Human Health at the College of Charleston. And as you heard, he also works in the area of human health and the oceans. And when GoMRI started, Paul was still at NOAA, where he was the senior science advisor to the administrator of NOAA. And then finally, Gene Turner over on the end, who is at, he's the Boyd Professor of Oceanography and Coastal Science at Louisiana State. And the website says you're interested in biological oceanography, conservation, environmental management, estuarine ecology, fisheries ecology, restoration, sustainable systems, and wetlands. So Gene can do anything, and has been a really active part of the Coastal Waters Consortium.
Both out of the Pleistocene.
We forgot Pleistocene? Okay.
Two of us.
So there were a few questions that the public had immediately after the oil spill that I'm going to ask people to tell us a little about. Gene, one of the big questions, especially in Louisiana, but also all the way across the Gulf states, was whether the wetlands would recover from such a massive spill. Can you tell us what we found out about that?
Well, in net aggregate, the answer is they are not, because they have been undergoing some loss already. And the peak of that loss was earlier, but they're still undergoing some loss. And so the oil spill apparently, as best I can figure out, caused about as much. It did increase the loss of the wetlands, maybe 300% for the first couple of years. But the amount of loss that's taking place is equal to the chronic loss, which has been done by permitting, for example, over a period of years. Every year, there's a little bit of loss from permitting, wetland dredging, and so forth. So the dramatic loss of the oiling is now coming to an end, and there are places where some restoration has helped, but mostly there has not been a net gain at all. There's been a continuing net loss. It just went through a higher loss for a little bit, and it's still going down. And then the elephant in the room, of course, is the upcoming climate change scenario, which will cause a lot of problems if it isn't already. So that's not a good story, but that's where we are.
Okay. Another big question that persisted quite a while after the spill was whether the fish were safe to eat. You showed us some nasty lesions, but anyone on the panel want to comment on how quickly the fish were safe to eat, and to what degree we can use that information for any future spills?
I'll try that one.
Okay.
Haven't been involved on both sides of the ball on this one. The Deepwater Horizon incident confirmed what we already knew, that because of the sophisticated systems in most fishes, they're able to actually metabolize most of the oil that comes into them. And so in terms of actual contamination of the muscle, which is mostly what people eat, it really never exceeded any environmental threshold in terms of public safety. And certainly that was probably, even if the closures weren't there, it's likely that in most cases that wouldn't have done that. Where we find the contamination, of course, is in the bile and in the subsystems in the liver, where these animals are processing it. That being said, at some point, the chronic re-exposure that happens in the Gulf is going to defeat that system. And so just because we didn't see it in Deepwater doesn't mean that we can't induce that problematic outcome where the system breaks down in the future. And so I think we need to be cognizant of the fact that there's only so much adaptive capacity in the fish to actually metabolize this.
Another question that we heard a lot at the beginning was how long the impact of the oil spill would last. And Cynthia, I know you have a perspective on this from your work with marine mammals.
Yeah, we've been looking, we have had two projects. One was the Reproductive Mechanisms Project to really understand the high failure rate. And so if you haven't been tracking that story, the success rate for pregnancies in Barataria Bay is only at 20%. And we haven't seen any improvement since the spill. And so we've really been trying to understand why. The second project is KARMA, which is really looking at these population trajectories and trying to figure out how long is it really going to take to recover. And Dr. Lori Swacky will be talking about that later this week. But unfortunately, even with the best case population scenarios that we're running, it looks like it's going to be at least 3 decades, and it could be much longer. And so, although initially, at the conclusion of the NERDA, we were seeing some evidence of an early recovery, some evidence of recovery, that has now gone away. And we are saying things are just as bad, if not getting worse. And so we are really dissecting that, looking at potential for chronic progressive disease, looking at the fact that we have animals that were impacted in their reproductive years, and so they're aging now, and looking at basically the overall environmental picture of Barataria Bay and these other oiled bays to really understand how are these kind of dolphins going to recover, and what are the best restoration strategies for something that takes that long. So hopefully we'll be able to secure funding for the marine mammal community to really continue to look at this problem. And then you add on the diversions that are planned in the freshwater, the salinity challenges that they'll face. So we are still very concerned about the dolphins and their long-term well-being.
And Steve, you mentioned the Deepwater fishes being long-term impacted, and some of the other fish groups. What about other parts of the ecosystem in terms of long-term impacts? Have other parts of the system recovered yet, Paul?
I would suggest that the human side of the ecosystem will have at least equally as long as the dolphins, the marine mammal side, to recover. The lessons learned from the Exxon Valdez, a huge oil spill at this time in 1989, but not on this scale at all, are that the psychosocial effects are still seen in studies done after 24 years, I believe it is, post the spill. And that spill also involved the litigation and payments and so on, and all of the social discohesion that followed the decisions of who got what, as well as the impact to natural resources, to individual family incomes, and the psychological stress that then turned to physical health issues. Some of the work, unfortunately not funded by GoMRI, but some of the human health work that has been done shows interesting trends in cardiovascular disease 5 years or longer after the Deepwater horizon, respiratory issues, those kinds of things, or at least the complaints of them. One of the huge difficulties here was that most of the human health, directly human health-oriented research did not start very rapidly post-Deepwater horizon. The part that Melissa talked about, getting surveys into the field within 30 days or a little bit longer, got started before the stuff that was funded through National Institutes of Health and others, the Gulf study, the Coast Guard study, and so on, that looked at the most exposed people, the workers and their families. So, you know, you missed that initial window, and there wasn't the baseline to work from. So I think from the human side, and I'll talk more about this, and we'll hear more about it in the session on Wednesday, but clearly there's going to be a need for long-term monitoring, long-term work on the human health side, and to be better prepared for the next time one of these things comes along.
Yeah.
So just to sort of go full circle on this, there are two what I would consider active reservoirs of Deepwater Horizon oil in the environment now. One is in the shallow water marsh areas, and certainly it's a highly reworked area. And also in the deep water, around Deepwater Horizon, Mandy talked about a lot of the benthic samples. The curious thing about the deep water is you would think that it would be coming landfilled and basically sequestered, but what's happening is we're seeing this both in the sediments and the biota, that we're getting resuspension events. And part of this may in fact be the oil itself and the oiled marine snow going downhill down that slope, and certainly, so what's happening is we're seeing this in some of the later ecological sampling as well. So in those two particular ecosystems, we're seeing active impacts, right? The interesting thing is we went down to Ixtoc, right? We did a 30-year retrospective, and we found it in the mangroves, and we found it in the deep sea. So it tells us a little bit about how long deep water is going to persist in the environment.
So to what degree will what we learn be applicable to the next spill? And Jean, I know you and I have talked a little bit about that. You want to comment?
The question is, what will we learn for the next spill?
Yeah, is Deepwater Horizon and what we've learned about it applicable to whatever comes next?
Well, this may be a little off target, but if you look at the Deepwater Horizon spill in the context of others, there's always many small ones, few medium-sized ones, and then one gigantic one. And the Coast Guard data that I had available, it's like a flood cycle. There's a few rare ones, and this one was right on the line. You know, you do a logarithmic plot, it was to be expected. So I think the next spill is not something we want, and the next spill to be avoided is to reduce the slope of that line so it's lower, so we have fewer instances of it. It's less frequent for the same amount. And that involves not the impacts, which is, well, you know, we all love what we're doing, I think, which is impacts for the most part. But we need to have the behavioral analyses to reduce, to prevent, to not fix it once it happens, but prevent it from happening to begin with. And I know people appreciate this point a little bit, but just that's a sociological or a political, not a political, but a policy issue. And just some common examples we have is that, you know, if it's community policing, you know, you take care of the graffiti and the broken windows and you fix them right away. Your grandmother can probably deal with your teenager easier for throwing trash out, or, you know, to pick it up easier than you can. There's different circumstances to make this work. If you put an electric meter inside the house versus outside, you go by it every day, and you're more conservative about your electrical use. There's all these little things that could be scaled up, obviously, to the social system, and we have no real analysis of that, of how to go about that, but it needs to start. So for the next one, I would say if we learn something from this is we can probably learn how to have sociologists, and I'm not, you didn't pay me to do this, but I'm just saying we need to have more policy people involved, anthropologists if you need, to figure out how to get the policy more robust, that we can prevent these things. Not so we're waiting to find out what happens with a horse out of the barn, but to keep them inside and not have these things happen. And that's what's missing, I think, so far, for the most part.
Melissa?
Just a couple of quick responses to the question. One, aside from the infrastructure we need for the social science research, In terms of policy, I think that we could do some simple things like requiring health and social impacts assessments as part of any federal funding, for instance, or if there's a new initiative set up, you could require that if you choose to put that in your master research agreement. But also, the Oil Pollution Act doesn't have anything about human health in it. Usually, it's post-event that we're looking at, human impacts and responses and how we aid people. But we could, especially in terms of policy, integrate ecosystems and human health better in any policy efforts. And I think that that's a really important thing to do before the next oil spill, whether it's a big one or a little one.
Great. Well, join me in thanking the panel.
Yeah.